Good morning, good afternoon. Welcome to another exciting session of taking control or command of your traffic. So this is really kind of a quick session that we want to talk through. What does NAT Gateway look like? What does NAT Gateway replacement look like? Why do we do it? What are the functionalities? What are the benefits? Kind of the why, how, and what does it give us? My name is Dan Sheldon. I'm the Director of Solutions Engineering for our European team. I come with a little over 20 years experience in the network and security engineering field, a little bit of everything from manufacturing to pharmaceuticals to, what have you. So very happy to have you here with us today. The goal here is to talk through the concept here for about 15 to 20 minutes, have about 10 minutes for questions. And then after that, let you guys be on your way with a little bit more information in your back pocket. So please feel free to throw some questions in the chat. I will try to get to every single one of them. And looking forward to a quick, interactive, informative session. So first and foremost, what is Aviatrix? What do we do? I'm a big fan of brevity and conciseness. If you were to ask us, what is it that you guys do? In 3 quick bullets, we simplify complexity, which is automating and orchestrating cloud-native networking. We improve security. So because of our unique purview in the data plane, we can do policy enforcement as close as possible to workloads. So it makes zero trust network access or distributed cloud firewalling very, very simple. And reducing costs, part of that is from the visibility that we have. The other part of that is there's a lot of CSP native constructs that are very, very costly, and we can replace those pretty succinctly. Where do we come from, right? So we were founded in about 2014, and in 2018, we were the transit gateway in AWS, right? So when VPCs wanted to talk to VPCs back in the day, they only had one option, that was VPC peering. We all know how complex that gets when you're talking about hundreds of VPCs. So our founder, Dr. Sherry Wei, came up with the idea of this is a router that lives cloud natively, and we can actually do kind of all the components you'd expect of a transit gateway, right? In late 2018, early 2019, AWS decided they liked that so much, they created the AWS Transit Gateway. We felt honored and validated, even the name was the same. But at that point, we had already kind of expanded our view on the world, right? So we had enabled the same functionality across Azure, GCP, OCI, Alibaba, et cetera. 2020, we decided, hey, with all this great connectivity that we had, let's go ahead and enable policy enforcement at all of those data planes. So we enabled our embedded network security and built firewalls everywhere that our network nodes were, right? So you can now do macro segmentation, micro segmentation, all of those components instead of having to do centralized, firewall policy enforcement. Fast forward 4 or 5 years later, now a little over 500 enterprise customers. This is an older slide, so it's about a little over 50 of the Fortune 500. I think it's 60 something now. Over 25 countries. I'm coming to you from the US, but obviously we have people all over the world. And again, just because we might talk about a few 10, 15, 20, 35 VPCs, some of our customers are more in the 5,000, 6,000, 10,000 VPC count. So very, very large workloads, very large recognizable logos. Trust us with their most, productive VPCs, workloads, and applications in the cloud. So what are we talking about today, right? We're talking about NAT gateways, right? There are quite a few reasons for this. It's a very timely conversation. Azure's released that they will be requiring NAT gateways on all egress traffic for new VMs starting September 31st of this year. So people that are in Azure that aren't utilizing any service like that, just utilizing the default internet access, that's going away. So what are other customers doing today within AWS, within Azure, within GCP, right? Generally, they look something like this, right? So within AWS on the left-hand side here, you might see, let's see if we can draw while we're doing this, right? Within AWS on the left-hand side here, you can see effectively we have the cloud workloads. They connect through NAT gateway. All this is doing is source NAT, right? It's basically saying, hey, we don't want this internal IP being broadcast out. It needs to be an external IP. It NATs and then sends it out. There's no enforcement. There's no inspection. There's no visibility generated. And all you're doing is you're getting hit 3 different times by billing. You're getting charged by the hour for the service. You're getting charged for every gig of processing, which is effectively every gig that's being natted. And then you're getting charged again for all of the traffic that's being egressed, right? So 3 pretty good sized charges for every gig of data that's going out to the internet. Plus, these could be going out to malware. It could be going out to command and control websites, you name it. It's not an ideal solution. It's pretty simplistic, but that is what it is. Those are the options right now, right? So let's talk about it a little bit more in depth, right? So these workloads will come out through NAT Gateway. They will get out directly out to the internet. These might be bad actors, right? We're not sure. The challenges are there's no observability. NAT Gateway doesn't give us any additional, view into the traffic that's exiting or egressing our cloud networks. There's no governance. There's no inspection. There's no ability to enforce policy at this point. There is no security to it, so there's no way to create a stopgap. IBM says that the average cost of a data breach within the cloud is about $5 million per company. So it's a significant cost for something that should be fairly simple to stop, right? It doesn't scale because we're managing a NAT gateway in every single one of these VPCs or VNets. And again, you can try and Terraform automate it as much as possible, but again, you're having to touch every individual gateway. And then of course, the costs that we just talked about. So why do we want to fix this? So we've got the kind of the business pains that we talk about, which are those cloud costs, lack of compliance, the potential for that $5 million, check for every time that we have a significant security incident, as well as your brand health and your customer trust. We all know what happens when you're in the news. Nobody that was a Cloudflare, user for the last couple of years has decided that was a good event that happened, right? So we want to avoid all that. We want to avoid any of the kind of the technical debt that we're going to deal with for slow troubleshooting, identifying noisy workloads, advanced inspection capabilities, all of those components. So there's got to be a better way, right? Obviously, you're here with Aviatrix. Let's talk about what our solution is for this problem. So we talked about all the issues that we've seen before. What if we changed these out and we started utilizing Aviatrix Cloud Firewall Gateway? So again, these are one-to-one NAT gateway replacements. We can do it in multiple availability zones. We can single arm it into a single availability zone. It's really up to your individual design choices. And what these are Aviatrix spoke gateways. They have the ability to do the NAT functionality that you're expecting. They have the ability to layer in observability because it's in the data plane. It can see all of the traffic and you can get all of the traffic visibility in a single pane of glass. You now have the ability to do policy enforcement. You can ensure that one policy that you set globally can be attuned to every NAT gateway that you have. You administer that from the same single pane of glass, automated, orchestrated, control plane. You can add that additional security. So if you have a bad actor on-prem or on your cloud environment that's trying to communicate out to the internet, they can no longer get out to that, malicious website or trying to do the data loss prevention, things like that, trying to do your data exfiltration. They're not allowed to do that anymore, right? So we have that policy enforcement component. It also scales because these are very small instances, right? So either EC2 or VM instances, much smaller than what a NAT gateway would utilize, but doing a lot more. And it's all controlled from a centralized control plane. So much more scalable, much more easy to deploy. And of course, cost-wise, smaller instances, those 3 charges that we talked about before, the cost per hour to run it, it's not there. The cost per gig of processing, we have no throughput ingress egress costs whatsoever. The only cost of those 3 that we still have to talk about is that data exfilling out of the cloud. We can't get rid of that yet. Someday, if we can, it's about $1 trillion idea, I would say, in the market right now. So stay tuned, I guess. But what does that look like in scale, right? So these are the spoke gateways that we talk about. So each one of these out here across Azure, GCP, AWS, OCI, again, we want that really homogeneous, standardized experience, regardless of which cloud you're connecting from. It shouldn't matter that you're in OCI versus GCP or AWS versus Azure, et cetera, right? We want to have that same experience regardless what we're doing. But it is a distributed perimeter, which means that it's in each VPC, in each VNet, you have your specific access out. And again, because everything is going through a centralized control plane, you have that centralized management, visibility, and control, right? So let's talk a little bit about what that centralized visibility and control looks like. If I get rid of my pen strokes, you have the ability to instantly see what your holistic egress security score is, right? So for every VPC VNet that you have onboarded that's trying to get out to the internet, you can instantly see what that security score is. You can see of all of the onboarded, VPCs, VNets workloads, you can see how many are protected, how many are unprotected, partially protected, protected, or monitored. And I'll actually walk through what those 4 different meanings are real quick here. And we have what our potential savings is over NAT gateways as well. So you can actually see in real time, this is how much money we've saved. Take a screenshot, send it to your CFO, hopefully have a really great weekend, right? So being able to see what traffic those workloads are trying to get out to, where are they coming from, where are they trying to get out to, what rules are being hit. Again, some of these might be very, very simple, where yes, we want to allow people to get out to Oracle, or they want to get out to AWS. But do we want to let people get out to botnet.com, or do we want to let them get out to ransomware.org? Probably not so much, and especially not 107,000 times. So how do we fix that? How do we make it easy to identify what traffic shouldn't be going out? How do we quickly identify which source IPs are doing the top talking out? And how do we confirm which of my, maybe 1,500 VPCs is protected or not protected at a glance, right? Let's take a look at it, right? So before we jump into the demo, one point of order, we talk about those 4 different flavors: unmanaged, onboarded, monitored, protected. Really what that looks like is unmanaged means that your workloads right now within that VPC or VNet are going out through a NAT gateway. They are uninspected. They are going out, basically being natted and have free reign of the internet. Onboarded means that you have deployed a Aviatrix spoke gateway in that VPC. So the hard part is done, so to speak, right? Again, this is very simple to do, so calling it the hard part might be a little disingenuous. That all the deployments for the VMs or EC2 instances is done from that centralized control plane, so you don't have to individually deploy any instances. Switching over to monitored means that you've enabled SNAT or SourceNAT on that VPC, which means your workloads are now going through that spoke gateway out to the internet. You've not enforced any policy. You're just allowing it to NAT, and you're allowing it to gain visibility. So it is now seeing all the traffic that's trying to egress. Where are those workloads trying to get out to? And again, leave it in, if you're familiar with IPS IDS, this is really IDS, right? It's learning, right? And then after, a week, 2 weeks, 30 days, what have you, we've got a really good idea what it's trying to get out to. That's when we shift over to this protected mode. Protected mode means we've built a security policy, and we are now enforcing that security policy that says, if you're trying to get out to somewhere bad, you're not getting out there anymore, right? So that's really kind of what those 4 buckets look like for us. So unmanaged, onboarded, monitored, protected. So that being said, let's see if we can do a quick demo here. And again, I'm terrible at screen sharing, but I'm going to try my best. Let's see. Okay, hopefully you're seeing my screen. If not, let me know in the comments. We'll figure it out together. So really quick, very micro environment that I'm dealing with here, because we're just talking about one specific feature set. So under security here, under egress, because that's what we're caring about today, you can see very quickly, this is what we're looking at, right? So we've got 10 VPCs and VNets that are onboarded. Of those, we're dealing with 3 that are unprotected. We've got 2 that are monitored, and we've got 4 that are protected, and 1 other that I don't believe we have any functionality on right now. We can analyze what traffic is kind of originating from those workloads today, and where are they going out to. So we happen to have a lot of traffic going out to aviatrix.com, no idea why, but we have quite a few that are going out to malware.net, Python, get some Python scripting, Oracle, reinvent events, things like that, right? So let's look in depth at kind of what these individual VPCs or VNets are doing. So we can see very quickly, we have the ability to enact these changes on multiple VPCs or VNets at the same time. So don't think that you just have to go in and say, I want to protect one. You can do that on all of them. So we could onboard multiple, protect multiple. But one of the things that we're going to talk about right now is the unprotected sites themselves. Again, when we talked about which of those 4 phases we're talking about, unprotected is there are no spoke gateways in that VPC. If we were to click onboard, we could actually deploy that spoke gateway in the VPC. That puts us into the monitored, or that puts us into a somewhat protected state, right? Where it's actually onboarded, but it's not monitored or protected. So to monitor, we enable source NAT in that VPC. So the traffic is then traversing through the Aviatrix spoke gateway. Once it's traversing through the Aviatrix spoke gateway, then it goes into a monitored state. So monitored state's great because it's learning. So if we go in and we say, okay, what have you learned? Let's go ahead and talk about protection. It's going to look at all of the kind of known or egress traffic that it's trying to get out to. And we have this fun little AI bot that is actually looking at exactly what is what those websites or URLs or FQDNs are trying to get out to, right? So it's going to pull up and say, hey, again, we think that this is a risky category that we're connecting to. Why, right? So botnet.com, this name explicitly references malicious activities or malware, not great. Or facobook.com is typo squatting, right? It's a variation of a legitimate domain. It's probably used for phishing activities. So we can click on our AI reference and actually have it come up and say, explicitly, why does it think that facobook is not the ideal scenario? And we can, hover over here and we can actually see what that AI confidence is for that particular, unit. So all it would take is being able to click in on these individual URLs and hitting that we want to create a rule set, and then we're done. It's as simple as that, right? So that is how very quickly we can change your overall security posture with the visibility that and natting that you expect from a NAT gateway already, all in one shot, right? So very, very quick to change, update, add that additional security control, that policy enforcement, and that visibility, while also saving costs on the back end, is really kind of what we're trying to do here. So it's very simple to deploy. We've talked about this before, but just for everyone's reference, if you are currently deploying just via NAT gateway, it's as simple as deploying that Aviatrix gateway. Again, this is done through our automated policy control through the control plane. We then switch our source NAT over to that gateway, which switches our traffic from the NAT gateway to our Aviatrix spoke gateway. We then decide to decommission that NAT gateway so we get rid of that cloud cost. And then we enable some policies on those. Oh, there we go. Then we enable some policies on that gateway, and then that will actually do any of our blocking for our malicious URLs, FQDNs. Next, yes, we can do it via the UI. I love the UI. It's a very pretty UI, but a lot of our customers are, I would say, much more mature than that, than me as well. And they want to do this via Terraform. That's great. I think our Terraform's at like 2.6 million downloads for our public Terraform registry at this point. Very, very simple to do this. Literally deploy the Aviatrix gateway. We can do that from Copilot, or you can do it via Terraform. We can do source NAT. Again, you can actually look at the individual code that we want to do here, and then we can decommission that provider NAT gateway as well. So just effectively falsify that enable NAT gateway. Very simple to do. Let me see. And again, I will share these links out after the event. But again, our Terraform registry, you can just search on Terraform registry for Aviatrix. There's additional demos on how to do this in real time on our YouTube channel. So just put in our YouTube channel on there. And that is really all that we ended up having to do on this one. Again, we want it to be really simple. We want it to be foolproof. We want it to do all the things that we would expect a service for enabling that egress traffic to do, which is enable additional visibility, enable additional security, the ability to actually enforce policy, ensure that malicious FQDNs and URLs are denied, and then also save costs at the end of the day, right? Why are we being charged that much for a very, very simple process? So that is what we're trying to do. That is how we're doing it today. And we have a lot of customers that are trusting us to do this that are somewhat happy with us, right? So let's go to a couple questions. I think I have, a question slide. Cool. So a couple questions that came up quickly. So from Suhaib, no VPC flow logs and Route 53 resolver logs enabled to get all this visibility. Yes, no, not required anymore, right? So to Suhaib's point is, do we need to utilize Route 53 resolver or VPC flow logs? Again, costly to actually pay for those. Then you also need something like CloudWatch in order to kind of resolve those and look at those in greater depth. And then you have to create a rule set, and then you have to find a way to policy enforce that. So you might have to download that to a centralized firewall policy, something like that. You don't have to do that anymore. No, this is all built in. There's no additional cost to do it. It's just inherent to the platform itself. And then does it give us any visibility into public subnet traffic? So I'd have to better understand the question. But yes, so anything going out to a public FQDN URL, this will give us visibility into that. It will also enable that AI bot that will determine whether or not that is a known malicious or unknown malicious website URL FQDN. And it will enable you to create a policy very quickly that disables that traffic. So hope that answered your question. If not, I can definitely get with you after the fact. But yeah, so this is today limited from a policy enforcement perspective to FQDN URLs. Any other questions that popped up? No. Good. Well, that means we were informative, right? That's what we're here for. So just want to thank you all very much for your time today. I hope this was quick, informative, lets you know exactly what we're looking at. And thank you so much for the time. Hope you have a great rest of the day.